Differential equations are equations that have a dy dx terms in them as well as x and y terms. You must be able to separate the x and y terms and not be left with any that involve both x and y. So your first step will be to get the y terms and the dy on one side and the x terms and dx on the other. Then you'll integrate each side separately, and then you'll rearrange it to get it in a nice format, for example y equals. Now don't forget, you still need to add c, the constant of integration, but you only need one. And sometimes in some situations you'll see that it will make life easier to actually write that constant as ln k instead. Doing steps 1 to 3 will give you a general solution. If you want a particular solution, then you need to obviously work out what that constant of integration, or the k if you go for the ln k version, is. So let's start with a very straightforward example here. So remember, step 1, we've got to get the y's and dy on one side and the x's and dx on the other side. So if we divide through by 3y, we'll get 1 over 3y dy on this side. And if we multiply both sides by dx as well at the same time, we'll get this like so. So now we're just going to integrate each side separately. So this first side is going to be a third ln y. We're going to need to think chain rule. So let me show you. We can sort of deduce that it probably started life as some version of this. So let's differentiate that and see what adjustments we might need to make to get it exactly right. So if you differentiate this using the chain rule, you'd get 2 minus x squared, and then you have to differentiate what's in the brackets, which would give us a -1. So that finishes up as -3, 2 to the minus x squared. So that's not exactly what we're integrating. So to make it fit what we're integrating, we're going to need to multiply our integral, if you like, by a minus and a third, and then that will make it right. Hopefully that made sense and you've looked at how to do this in other situations. That's going to give us, as I say, minus a third, 2 to the minus x cubed, and we'll put the c on this side. I'm going to get rid of the 3 element because it's on both sides, and I know I'm not really dividing the c by 3, but we don't really know what c is anyway, so it doesn't matter. So it's ln of mod y equals minus 2 minus x cubed plus c, and that I would suggest is the nicest way to present that, so I'm going to leave that as it is. So now we're going to take that into a more involved question. So here the population of dormice in a particular area is decreasing at a rate that is directly proportional to the current number of dormice d. Formulate a differential equation to model the rate of decrease in terms of d and t, the time in years, and m, a positive constant. Okay, so you might have to actually create your own differential equation from the wordy stuff to start with. So in this case, this would be d by dt, so that's the rate of decrease, will be equal to minus md, because we're told it's proportional to d, but we're also told it's decreasing, so that's why it's minus. If you think back to doing direct and inverse proportion, you'll remember that you usually use K as the constant. Here I'm just using M. Having got our equation, which I'll rewrite here just quickly. Now we're going to use that for this question. It says if the initial population is 80, solve to find D in terms of M and T. So we need to get rid of this differential, and therefore we need to integrate. So remember, we need to get all the D's together and the T's together, so to speak. So I'm going to divide through by D, which will give me 1 over D dd. And then on the other side, I'm going to have my minus M dt. And so we're going to integrate each side separately. So that's going to give us ln D on this side, and on this side we're going to have minus mt plus our constant of integration. Now we need to get rid of that constant of integration because it said we're only allowed to have D in terms of M and T. So we were told that the initial population, so when T equals 0, then the initial population D is 80. So using that in the equation we've got here, we can see that that's going to give us ln of 80 is the same as C, because the T will have disappeared there. So we found our C. So altogether our equation is going to look now like ln D equals minus mt plus ln of 80. So let's just try and rearrange that and sort that out so it looks a little bit nicer. So let's bring the logs together so that we can do something with those. So that's going to give us ln of D over 80 equals minus mt, and then obviously using the exponential on both sides, we're going to get D over 80 equals e to the mt. So D will equal 80 e to the minus mt. So third part of this question, we're going to need what we've worked out so far. So I'm going to just copy that in. So we just found out that D was equal to 80 to the minus mt. So in this section we've been told that m equals 0.2, and we've got to find the number of whole years that it takes for the dormice population to drop below 30. So we're going to find out how long it would take to get to 30 exactly, and then interpret that in terms of the question. So our D is going to be 30 and our M is now 0.2. So that gives us 30 equals 80 e to the minus 0.2 t. So let's take that one step further. So that's going to give us 30 over 80 equals e to the minus 0.2 t. And obviously that can be simplified to just 3/8 there. So take logs from both sides. So we're going to have ln of 3/8 equals minus 0.2 t. So t will equal ln of 3/8 divided by minus 0.2. And with the aid of the calculator, you'll find that that comes out at 4.9 years. but because they've asked for the number of whole years, your actual answer therefore would be 5 years.